Hey class, welcome back. If you check out the video today, it's a little bit more of a free-form video. Today's this Tuesday that we have off for the students, although the teachers are here in their classrooms or they're at home Zooming with other teachers. So let's jump right in, and I want to talk a little bit, obviously about our curriculum, but a little bit about how to succeed in the class as well. Now that we're into week 8, we've had an introduction to the curriculum, where we're going with this. The focus is mainly on biology, but we talk about all the other sciences. And if you check out the board behind me, you don't have to write any of this down. I wrote it in cursive mainly to remind myself what to write about. But if you also check out the notes, there will be some notes posted down below on pacificascience.org as well, and in your Google Classrooms, to make sure you get on down in your notebook, your interactive student notebook, really important part of the class. And I think one of the things I want to start with is the subjects that we've touched on in the first 7 weeks. It's really important that we have an idea that, the things that we've seen here when we talk about light, we talk about the age of the universe, we talk about DNA, we've talked about how long life we think has been here on this planet. You're talking about things that in the last century we didn't know. You're talking about things that if you could go back in time and talk to anybody 100 years ago, you would blow them away with things that we've talked about, we've touched on just in the first 7 weeks. There's a lot of things that easily you could spend a whole trimester talking about. The nature of light, the nature of cells, the history of life. All these subjects come together when you're talking about life science, which is awesome. So let's talk a little bit about, succeeding in the class, really understanding the material. I have a test out there online right now. It closes Friday at 3 o'clock. And a couple of students, almost the second I put it out there online, flew in to take the test, which is awesome. I understand that you're anxious to do that. I really want you to slow down and take in the material. One, it's science, the coolest subject. Don't tell any of the teachers I said that. But it is just absolutely amazingly awesome, the things that we're talking about in this class. But two, we have to kind of put it in some context. How do you remember? How do you take in all the things that we've talked about? So let me put on my glasses so I can see here and check out a couple of things on the board behind me I wanted to make sure to mention. One, outline format. Why outline format? Well, first of all, it says, thanks, Ms. Satui, my old 7th and 8th grade teacher. If you check out outline format, it's the way we do the notes. We're using it right here. As a matter of fact, I went a little bit silly with it. Roman numeral 1, then an A, then a number 1. You can look up Roman numeral outline format yourself, but the point is it's a great way to organize yourself, not just in this class, but in any class. Say you're taking class over with Miss Woods, for example, and she has you write an essay and you need to organize your thoughts before the essay. A fantastic way to do it, a fantastic way to say, hey, what's my 5-paragraph essay if I'm doing one of those? What's it going to look like? What are the talking points? What are my paragraphs going to look like? This is a great way to organize your information, and we'll be doing this more, and especially doing this with our textbook, trying to make sure that we understand the material in the textbook. Outlining is a fantastic way to do it. Also, graphing. We've talked a little bit about graphing in the class. One of the things, and I'll go into it more on the part of this video where I'm off screen, how do you graph your results from an experiment? One of the things I've been trying to get across is don't just take my word for it. I want you to think about how we know what we know. And one of the things is putting for example, the independent variable on an x-axis and the dependent variable on the y-axis. One of the things I want to show you on the offline portion, when I show you some pictures later on here in the video, is the age of the universe. I mentioned, might be getting a little gray now, but I'm not 14 billion years old. How do we know that the universe is 14 billion years old? A gentleman by the name of Edwin Hubble, an astronomer, you may have heard of the Hubble Space Telescope, plotted the distance to distant galaxies, to galaxies very, very far away, against the speed with which they're moving away from us. And in general, he found that the further you go away from us, here on Earth, the faster things are moving away from you. This was one of the first things that led us to think that the universe is expanding from one beginning spot. And so you say, okay, well, if I run this movie backward, if you will, when was everything together in one spot? And we come to the answer of about 14 billion years ago. How did we do that? With some of the techniques that you've seen already. You might remember that a little while ago, we did an experiment with a string and a pendulum swinging on the string. We did that to show a little bit about how we graph our results and also to teach about independent versus dependent variables. This is how scientists help us figure out what we know. That's the cool part. It's what I love about science. you make guesses, but then you test them. It's like Feynman said when we had the early quote, you can have the greatest idea in the world, but if it doesn't stand up to experiment, it's wrong. You have to test it and show that your results fit with experiment, which is awesome. And then moving on here, I talked a little bit about Hubble already. Observations. We wanted to make sure that students are starting to get really into observation skills. Remember the Fleming story. He checked out a mold that had affected his bacteria experiment and realized that this penicillium mold was killing the bacteria. He ended up accidentally discovering penicillin. When I say accidentally, it was really due to his great observation skills. A lot of people might have overlooked this part because it was initially considered a failed experiment, but then he's like, hey, wait a second. There's something killing the bacteria. Penicillin, just about 100 years old right now, and that's the result of the scientific method and great observation skills. And we did a little bit, and I wanted to remember this over here. On light, we talked just a tiny little bit about light, and I wanted to remember to talk about light because we know almost everything about the universe, about the things that we check out in class from light. Light reaching our eyes, light is carrying information. That's why we talk a little bit about the physics of light, how light travels as a wave. And you might remember, for example, we did a little bell curve over there. It might look kind of familiar as a dice experiment. So check out the bell curve that we had over there. That shape shows up all the time. We talk about statistics, probability. It shows up in physics in amazing ways, which is awesome when we talk about a little tiny bit about quantum mechanics and things like that. Just a little bit about how atoms work. And again, even mentioning something like quantum mechanics, quantum physics, it really just is meant to point out that we don't have all the answers yet. You've got different sorts of physics. You've got relativity and quantum mechanics. They don't talk to each other. What does that mean? Even if you don't know what those terms mean yet, you will. But the point is, we don't have all the answers, but the scientific method over the last 100 years has really led us into getting an astonishing amount of scientific knowledge in the last century. Check out this. We did this experiment in class, and this is a quick example. I'm going to tilt my camera down for just a second. We're rolling some dice. We said, okay, a little bit about probability. What are the chances, for example, of rolling a 1? Well, if you've got a fair dice, as they like to say in probability, your chances of rolling a 1, you can probably guess, are 1 in 6. Might take me a couple rolls. Hey, look, okay, I got my 1, and it takes about a 1 in 6 chance. What are your chances of rolling snake eyes or 2 ones with 2 fair dice? Now, I'm not going to spend the time to do it, but we did an experiment at home on probability and statistics, and you may or may not have figured out that it takes a 1 over 36 chance, or about 2.5% chance of rolling snake eyes. Tried to explain that maybe the beginning of life on our planet 4 billion years ago is a little bit like probability. If you look at a 2.7% chance, it's a chance of rolling double 1 with 2 dice. It's not a very good chance. If someone said, okay, would you bet on that chance? Well, maybe not. 2.7% isn't too great. But if you roll it enough times, as I hope I showed you with that experiment, eventually you will roll a 1 and a 1. Some other things come up more often, and we're going to talk about that because that bell curve comes up all the time. Everything from our grades to when we talk a little bit later about the radioactive decay curve. It shows up all the time. It's not too likely you're going to roll this, but it will happen eventually. Check this out. What if I roll, say, 3 dice? What are my chances of rolling triple 1? What if I roll that many dice? What are my chances of rolling ones on every one of those dice? Not very likely. But if you give it enough time and you roll that many dice again and again and again, eventually it'll happen. It might take a very long time. This is where things like we're studying in biology cross over with things like astronomy and geology. Yeah, it might not be that likely that you get all these chemicals together and boom, you're going to get life. But you got to remember, our universe is 14 billion years old. Our planet is 4.5 billion years old. If you give it enough time, life just might be inevitable. It might be like I sounded like Thanos there for a second, inevitable. It might be just a matter of giving the chemicals and the conditions enough time. And guess what? We know now, using the scientific method, that our planet has had the time. 4.5 billion years is a long time to get the conditions just right to make life occur. So if you're checking out what we're learning in this class, we're talking about the big questions. Where did life come from? Where are we going? How do humans affect every branch of the tree of life that we're talking about right now in class, in chapters 1 and chapters 2. All right, I'll do the rest of this offline. Have yourself an awesome day.